10. A lorry of mass 32,000 kilograms travels at a velocity of 24 meters per second when it collides in the back of a car of 2,600. So you got your big truck here, and that's 32000 moving at 24 meters per second. Crashes into this guy here, 26, just like your bus story, 2600, and he is at rest. Yeah. So first thing is calculate the kinetic energy of the lorry before they crash. So part A. Remember the formula for kinetic energy? A half mv squared. A half 32,024 squared. Nine two 16000 joules. B. Determine the velocity of the lorry and the car after they crash. So they're going to crash and move off together.
So
Yeah, what's wrong?
do they give the main idea of the visa after the collision?
What do you mean?
Like sometimes they will collision and they will go.
I don't think we'll ever do that because you need another formula to solve that problem. I don't think that.
Normally they will move.
Oh, I'd be very surprised if that didn't happen. Yeah, it should move together. Unless if it didn't, you would have to be told some relationship with the velocities afterwards. So here, they're going to move off together as a blob of mass. What was it combined? 34,600 would be their total mass, and their velocity you don't know, and that's what you want. Right, so what formula do we use here when we're talking about collisions? Momentum. Yeah. So the momentum before the collision equals the momentum afterwards. So M1U1 plus M2U2 equals. Okay, so that's not a very complicated equation. You know this formula? I'll write it down for you. I'm sure you know this one, Amro. Here, let me write it down here on the side. M1U1 plus M2U2 equals M1V1 plus M2V2. Or in other words, the momentum before the collision equals the momentum after the collision. Alright. Sliding back now, Amro. Okay. So that's the answer to part B. So part C now is determine how much kinetic energy is lost. So that means we should find the kinetic energy after the collision. Yep. So the kinetic energy after the collision will be a half v squared, which equals yep 8523468 joules. Yes.
So you can figure out what was that after part A?
Yeah.
32.
32,000.
Yeah, and after that.
24 squared. So therefore 692532 joules was lost. Or if you want, you can say that's roughly 693 kilojoules, if you wanted to.
But in the last 3 D is different.
No problem, still full marks.
Because I use 22.97.
You need to be correct the 3 significant figures. So, there you go.
If I don't correctly.
No, it's fine as well. I will just check that you are correct the 3 significant figures.
The first 3 is matched to the answer, then is wrong.
D. So what happens is, here's the car, and it's or here's the crash wreckage, and it's going 22.19 meters per second, and then it will slide to rest. And how long of a distance does this take?
53.
It takes 53 meters. So the reason it's sliding to rest is because it's slowing down, because of the force. So what information do you have here for this problem?
The S.
You have the S. What else do you have? The U, and what else?
V.
And the V. So what formula would be best to use? Yeah, we could say V squared equals U squared plus 2AS. Now let's see what we get for A.
It should be negative, right?
Definitely should be, because it's slowing down. So I got A equals minus 4.65 meters per second squared. But he doesn't want the A, he wants the force. So how can you convert an A to an F? F equals ma. So just take this answer and multiply it by 34600, and we get minus 161 roughly 000 newtons, or roughly minus 161 kilo newtons, if you want. I'll let you write it down, but let me just stop the recording.